Okay, so this lecture is going to talk about a concept that we use in science and in math sometimes called significant figures. We like to call them sig figs in this class. Significant figures are digits that are found within a number that are considered important, and so therefore we have to maintain their integrity when we work problems. So the easiest way to do this is to discuss some rules that you use whenever you are searching for significant figures, and then for us just to practice some problems determining the number of significant figures that are found. So throughout this whole unit, as you work problems, I always have students that say, how many numbers do I round to? What place after the decimal do I round to? How many numbers do I need to show in my answer? Well, today's going to answer your question, because from here on out, any math problems that we do, your answer will always be expressed in significant figures. And you've probably heard me in some of the previous lectures that I've given where I say, okay, I'm going to round it like this because of significant figures. We'll go over that later. So here's the later, okay? So there are 4 rules when determining how many significant figures are found in a number. So we're going to start with rule number 1. And rule number 1 just tells us that digits that are found from 1 to 9 are always significant. Okay, so digits from 1 to 9 are always significant. So that means the number 1, 2, 3, 4, 5, 6, 7, 8, 9, if they show up in a number, that means that they are significant. So if I gave you the number 421 and asked you how many significant figures there were, you would say 1, 2, 3, because there are 3 digits that are one of these, 1 through 9. If I asked you how many significant figures were in 9,822, you would say that there are 4 significant figures because there are 4 digits that fall between that 1 through 9. If I gave you 1,432,111, you would say that there are 7 sig figs because all of those numbers fall in that 1 through 9, okay? So rule 1 is pretty easy. Just if it's anything other than 0, we say that it's always significant, okay? So let's move on to rule number 2. So rule number 2, we start dealing with zeros. Zeros are what give us problems when we're talking about significant figures, because sometimes zeros are significant, sometimes zeros are not significant. So rule number 2 gives us one instance when zeros would be considered significant. So zeros between 2 other significant figures are always significant. So if I gave you the number 107, we know that 1 is significant. We know that 7 is significant. And this 0 becomes significant because it is between 2 significant figures. I call this the sandwich method. So that means that we have 3 significant figures. What about 406? That would be how many sig figs? 3. Because the 4 is significant, the 6 is significant, and that 0 becomes significant because it is sandwiched between 2 other significant figures. Let's look at this one, 1,001. 1 is significant, 1 is significant, and both of these zeros are significant because they are sandwiched. So that means we have 4 significant figures. If I gave you 7,000,003, the 7 is significant, the 3 is significant, and all of these are significant. So that's 1, 2, 3, 4, 5, plus those 2. That's 7 significant figures because these are sandwiched. So any 0 that is between 2 other significant figures, they are considered significant as well. So that's rule number 2. Okay, so let's go on to rule number 3. Rule number 3 is the one that gives people problems. The rule states that one or more additional zeros to the right of both the decimal place and another significant figure are significant. But I don't like that definition, so instead I use the one that my chemistry teacher taught me. Final zeros after the decimal are significant. I tell students that when you write a number like 1.2, that's good, but if I say 1.20, that shows that I am being very precise. Perfect. You know, this could have been like a 2 or a 3 and it just didn't round up. But when I show 0, that means that I have 1.2 on the money. So this 0 becomes significant. So if I was counting how many sig figs, that would be 1, 2, and this 0 is significant because it is the final 0 after the decimal place. So that means I have 3 sig figs. Look at this one, 746.30. So 7 is significant, 4 is significant, 6 is significant, 3 is significant, and this 0 is significant because it is the final 0 after the decimal place. So that means I have a total of 5 sig figs. Okay, so let's look at this one. 1.0030. Okay, so 1 is significant and 3 would be significant. These two zeros are significant because they are sandwiched, and then this 0 is significant because it is the final 0. So that means that all 5 of those are significant. This is the one rule that gives people problems. So I always tell students, if you finish a number and after the decimal you see that there is a 0, just remember that it's going to be significant, okay? So the last one is rule number 4, and it just tells us that when we have zeros added to numbers to be used as placeholders, they are not considered significant. For instance, 4,000. That 4,000, this is not the final 0 after a decimal place. It is not a non-zero digit. It is not sandwiched, so none of these are significant. So this only has 1 sig fig, okay? Now those zeros are important. If I was expecting a check for $4,000 and one came that said 4 instead, I'm gonna be pretty mad at you. So when we say they're placeholders, it's important that we have them to put this 4 in the thousands place, but they are not considered significant to the math problem. Let's look at another one. Let's do 100. How many sig figs would that be? 1. The 1 is significant because it's a non-zero, but these zeros are just placeholders. So that's 1 sig fig. Let's look at this one. 1 million. How many sig figs would that be? Still just 1 sig fig. And that's because this 1 is a non-zero digit, but all of these are just placeholders. They are not sandwiched. They are not the final 0 after the decimal point. But let's say that I did this. Now, how many sig figs would that be? So this 1 is significant. This 0 is significant because it's the final 0 after a decimal. That means that all of these are significant as well. So my total number here is 8 sig figs. So if you follow the rules, you can always find out how many sig figs you're going to have. So I'm stopping the video right here. You have a worksheet where you just go find the number of sig figs for different numbers. And then I'm going to encourage you to go watch the next video, which is using the sig figs to do math. And that is extremely important because that's what the rest of this class will be about, is doing math and getting the proper number of sig figs. So I'm going to sign off right now. And then after you've practiced finding the number of sig figs, go watch the next video on doing math with sig figs.